Discrete Probability Distributions. Example 3. So we have a box with 5 marbles, 2 red, 3 blue. We're going to randomly select 2 marbles without replacement. So you take out the first marble, it stays out of the box, and then you randomly select your second one. So we are doing random selections here. So how many blues could you possibly select? And we can represent the number of blues selected with uppercase X, the discrete random variable which represents the number of blues selected. So we could say that we've selected 2 reds, which means the number of blues is 0. We could have a red and then a blue then a red, that's 1 blue selected with those outcomes. Or we could have 2 blues selected. So we can see that X could take a value of 0 or 1 or 2. And we can represent the probabilities in a table. Now to work them out, we could use a tree diagram like this. So here's the first selection and here's the second selection. The first selection, there were 5 marbles in the box, so the denominators here for my probabilities are something out of 5. In my second selection, there were 4 marbles in the box because 1 was taken out, so these are all something out of 4. And you can verify the probabilities, they're straightforward. If we work out the probabilities, we get these. So for no blues, which means we've got 2 reds, it's this path. So if we multiply them, we get 2 over 20. For 1 blue, so red blue or blue red, so if we multiply along the branches then add the probabilities, we get 12 over 20. And then finally for 2 blues, we multiply these probabilities to get 6 over 20. So now we can calculate probability based on this probability distribution table. So Px less than 1. So less than 1, well, there's only 0 in the table that's less than 1, so this one is 2 over 20, or 1/10, or 0.1. Px equals 3, there is no 3 in the table, so the probability for that is 0. Px equals prime, 2 is the only prime number, so 6 out of 20, or 0.3. In the table I've left the probabilities as fractions in their exact form, and I've used the same denominator, so it aids doing calculations. I can easily tell that if I add these together, if I add the numerators, I get 20, and 20 out of 20 is 1, so I know they add up to 1. So it could be helpful if you have the same denominators throughout. And it's worth noting that all of these probabilities are conditional. They all depend on the color that was removed before. In the examples shown so far, the discrete random variable X took values which are integers. Now they don't have to be integers. So if I take this example and modify the outcomes on the spinner to these numbers, then the probability table will look like this. And now the discrete random variable is still taking fixed predefined values. These are discrete values. You can't have any value in between these. They have to be these outcomes only. This is our sample space. But they are decimals, and that's not an issue.